Hey everybody, in this video we are going to be covering Module 6 from the review packet. This is questions 17 through 24. So Module 6 was all about word problems. This was a mixed bag of questions. All of them are word problems that incorporate other concepts that you've already learned. So it's really just about translating the words in the question into numbers and symbols and whatnot. So in each of these questions, I'll kind of walk you through my process on how I would translate things into equations and numbers and whatnot. So number 17 here says the difference between 4 times a number and 76 is -4. What's the number? So there's a lot of different pieces here. I kind of like to start with these questions a little bit um, from the back because oftentimes the way things are phrased and worded implies that you have an understanding of the order of operations. But if you read it in order from beginning to end, you may not write the equation correctly. So starting from the end of the sentence, it says is -4. That word is like an equal sign. So when you have is -4, I write it like that. And then that kind of helps me build my equation to find that is wherever it is in the question. Usually it's somewhere towards the end of that sentence. Now we can kind of dissect the other parts where we see the difference. We see a difference, so we know there's subtraction somewhere. We see 4 times a number and 76. So when we see a number, think of that as x. We don't know what it is. So we got 4x and 76, and it says the difference between them. Right, so reading it out now, difference between 4 times a number, so 4 times x, and 76, so there's 76, so the difference between them is -4. So this helps set up the equation now, and since it asks what is the number, you can now go forth and solve for x. So I'll kind of leave that for you to explore after that. It's just solving an equation just like we've done in the past, but I think the main part about it is how do we get to this equation? We dissect the various words and phrases in there. Number 18 says write an expression for a number -7. So again, a number is like x, and now you can kind of see there's a minus there and 7. So there it is, x -7. Pretty straightforward. Number 19 says the product of a number and 4 is 27. So when you see this word product is another way of saying what happens when you multiply two things. So product of a number and 4. So a number and 4 is like 4 and some other number that we don't know, 4x. The product would be 4 times x. So that's why I put the numbers right next to each other, 4 right next to the x. Then we have is, so that's an equal sign, and then 27. 4x equals 27. Now I trust you can figure out from there what does x equal. Number 20 says a patient lost 23 pounds over 6 months. Their new weight is now 219 pounds. What was their initial weight? So to kind of set this up in a different way than the previous ones, I would just kind of write the word initial minus how much they lost equals their new weight. So I kind of phrase it like that to help me place the numbers, right? So they lost 23 pounds, right? So that's going to be right here, minus 23. So we lost 23 pounds, and their new weight, where they currently stand, is 219. And what we don't know is what their initial weight was. What was this? I'm just going to rewrite initial right there, because now this is like an equation. You could think of it as like x minus 23 equals 219. We can just add 23 to both sides to figure out where did they start off. So that leaves us at 242 is what their starting weight was if they lost 23 pounds. All right, let's keep going. Number 27 or 21 says, for every 8 grams of medicine, you need to dilute it with 5 grams of saline. If you have 70 grams of the medicine, how much saline do you need? So we can set this up in a couple of different ways. To visually just see this, we could write the 8 grams right next to the 5 grams as a proportion, 8 grams to 5 grams, right? And we can kind of label the first one the meds, and the second one is the saline. And then what we're being asked is if we have 70 grams of the medicine, how much saline would we need? So if we translated this into more mathematical terms, we could turn this into an equation. And I wrote it just like I see it, 8 over 70, and then 5 over, and we don't know what that is, so I put an X there. And so before, in module 2, I believe, we would do what's called cross multiply, and we get 8x is equal to 350. And then we would continue to solve it from there. Just like that. Right, so that's how much saline we would need, 43.75 grams. Number 22 says, based on the patient's age in months, the initial dose must be reduced by 1/4 of their age in milligrams. If the initial dose is 292 and their dose is 124 now, how old is the patient in months? So we need to figure out how much it was reduced by. We can start with something we wrote before. So we have initial minus the reduced amount is equal to their dose. And if we take the 292 as their initial dose, and we think about, well, we're not sure how much it got reduced by, but we do know that their current dose is 124. There's a few ways we know how to determine the reduced amount. We could move this equation around a little bit and try to figure out the reduced amount. But either way, we want to figure out 292 minus what number equals 124. So whatever way you try to approach that, you should end up getting that amount is 168. That's the reduced amount. And we're trying to determine how old is the patient in months. Well, since we reduced it by 168, that should be 1/4 of their age. So now we take that 168 and it's 1/4 of their age. So now thinking of that like an equation as well, we could multiply both sides by 4 to get their age. And when we do that, we get that the patient's age in months is 672. So there's number 22. Number 23 says a wound dressing is 54 meters long. You need to cut it into 2 pieces so that one is 12 meters longer than the other. What's the length of the longer piece? So visually, it helps to understand what's going on. Think about you've got your wound dressing, the very long piece of fabric or cloth or gauze, whatever it might be, right? And in total, it's 54 meters. And you want to cut it somewhere. Do you want to cut it only in one specific spot? So I'm just going to make an arbitrary cut right there. Now we want to make sure that that cut results in 2 pieces where one is 12 longer than the other. So let's just label the 2 pieces. Let's label the longer piece as A. And since it's a longer piece, the other piece needs to be 12 meters shorter than A. So A minus 12. So now if we were to think about in total, since it's 54, we know that A, if I were to combine them, A plus A minus 12, right? I'm adding this with this, A plus A minus 12. Well, this is going to be equivalent to 54. Well, combining like terms, we have A plus A, so that's 2A, minus 12 equals 54. And if I continue to solve this, couple more steps, then we get that the longer piece is 33 meters. And now, if the longer piece is 33 meters, then the other piece has to be 33 minus 12, or 21 meters, right? 33 and 21 are the two lengths, right? 33 plus 21, just to make sure, is still 54. That's good. And we want that because we know that the 2 pieces have to add up to 54 and that one of them is 12 shorter than the other one. What's the length of the longer piece? Well, the longer piece is right there, the 33 meters. The shorter piece, if it asks for it, sometimes it might ask for the other one, is 21. Number 24 says you've been tasked with determining the amount of funding for 3 projects. The budget is $7,200, and it gives us some information about how each of the projects are related to each other and how much. The question is how much is needed for each project. So the first thing is that all 3 together have a budget of 7,200. That's for sure. A plus B plus C is 7,200. But they're not all equally budgeted. The first sentence says that A must be 1/3 of project C. So I'm going to say A is 1/3 of C. So that's the first part of that sentence. And then it also says, and project B must be twice of project C. So project B is twice of C. And so when we have these two pieces of information, we should insert them into this equation for A and B. So instead of putting A, we're going to put 1/3 C. And instead of B, we're going to put what it's equivalent to, which is twice of C or 2C. And the last one is just a C, so let's just leave it there because now all of our variables are project C. So now looking at all of this, we have 1/3 C, 2C, and 1C, I guess you could call it. And if we combine them, since they're all like terms, let's see, that would be 3 1/3 C. So I'm going to put 3 1/3 C equals 7,200. Well, I don't really like this mixed fraction here, mixed number. So I'm going to change it to 10/3 C because I want to figure out what's C. So to do that, we would multiply by 3 and then divide by 10 over. And when we do that, we get C equals 7,200 multiplied by 3 over 10. It's really just flipping this fraction and multiplying it over here. When you do that, you get the amount for project C was 2,160. So once we know what project C was, we can go back over here and figure out what A and B are. So for A, we know that it's 1/3 of C. Well, if we know that C is 2,160, we just do 1/3 times 2,160. And so then for A, we get that this is 720 if you punch it into a calculator. And B is twice of C, so that would be 2 times 2160. So that's a total of 4320. And there's each of the project amounts. And that brings us to the end of Module 6. So again, if you have questions about any of these, feel free to reach out, let me know. In the next video, we're going to be talking about Module 7.